Everything you see in the night sky, every star, every glowing cloud of gas, every structure humans have ever mapped is just one tiny corner of something unimaginably vast. Because beyond our Milky Way lies a universe filled with islands of stars, swirling in silence and separated by oceans of darkness. These are galaxies, the great archipelagos of the cosmos. And to understand them is to understand the history of everything from the birth of stars to the fate of the universe itself. Welcome to Mattermosaic, piecing together the universe, one discovery at a time. Today, we're journeying across the cosmic sea to explore galaxies, what they are, where they come from, and what they reveal about the invisible forces shaping reality. A galaxy begins with a whisper, not a roar. Tiny fluctuations in the fabric of the early universe, subtle ripples in density only 1 part in 100,000 different from the space around them. But gravity is patient. Those tiny ripples became seeds, and over hundreds of millions of years they drew matter inward. Hydrogen and helium pooled into the first clouds. Clouds became clumps. Clumps collapsed into the earliest stars. Light returned to the universe, and the first galaxies, small, chaotic, and faint, were born. Most galaxies start small. The early universe was crowded, wild, and dynamic, filled with collisions and mergers that reshaped these young star cities. Galaxies crashed together the way tectonic plates collide on Earth, but instead of breaking mountains, they built giants. The Milky Way is one of these giants, formed from dozens of smaller galaxies consumed over billions of years. Even today, it's still growing, absorbing the Sagittarius dwarf galaxy and slowly pulling in the large and small Magellanic clouds. Galaxies are not static. They are ecosystems of motion and evolution. Spiral galaxies like ours are the most iconic. They're beautiful. Pinwheel arms sweep across space, glowing with young blue stars. But these arms aren't rigid structures, they're density waves, like traffic jams of stars. A star enters the arm, slows down slightly, shines bright among its neighbors, and then eventually moves out as the wave rolls on. Inside a spiral's heart lies a bulge of older stars and, at the very center, a supermassive black hole millions or billions of times the mass of the Sun. For the Milky Way, that black hole is Sagittarius asterisk, a silent giant that shapes the flow of stars around it. Elliptical galaxies are a different story. Instead of graceful spirals, they resemble enormous spheres or cigars of stars, smooth, featureless, and old. They're the result of cosmic violence, massive collisions that scramble stellar orbits until no structure remains. These galaxies can be enormous, some containing trillions of stars. In them, star formation has mostly ended, leaving behind vast collections of ancient suns slowly drifting through time. Then there are irregular galaxies, cosmic misfits without symmetry or order. Some are small and lopsided, others appear torn and stretched by the gravity of nearby giants. They're the universe's reminders that not everything fits into tidy categories. Every galaxy, no matter its size or shape, is built from 3 main components. The first is stars, hundreds of billions of them, each with their own planets, moons, and chemical histories. The second is gas and dust, the raw material for new stars and the fuel for cosmic evolution. And the third, the most mysterious of all, is dark matter. Though invisible, dark matter outweighs everything else combined. It acts like a cosmic glue, creating gravitational scaffolds that allow galaxies to form and stay together. Without dark matter, galaxies would fly apart, stars would drift away, and the universe would be an empty, expanding void. Dark matter reveals itself not through light, but through motion. When astronomers measured how fast stars orbit the centers of galaxies, the numbers didn't add up. Stars far from the center move too quickly, as if pulled by an invisible mass. That invisible mass, spread throughout a galaxy in a vast halo, is dark matter. To this day, no one knows exactly what dark matter is, but galaxies tell us it's there, shaping everything. Galaxies aren't alone. They gather in families, groups, clusters, and even superclusters. The Milky Way is part of the local group, a collection of more than 50 galaxies bound together by gravity. Beyond that lies the Virgo cluster, the Laniakea supercluster, and the cosmic web, a giant structure of filaments and voids that stretches across the observable universe like a neural network of galaxies. The universe looks less like a random scatter of stars and more like a living organism, filaments of matter, nodes of galaxies, and vast empty spaces in between. Some galaxies are active, so active, in fact, that their centers blaze brighter than the combined light of all their stars. These are quasars and active galactic nuclei, powered by supermassive black holes, devouring matter at incredible speeds. As gas spirals inward, it heats to millions of degrees and releases torrents of radiation that can be seen across billions of light years. Some of the brightest objects in the universe come from galaxies whose cores are anything but quiet. As galaxies evolve, they shape the chemistry of the universe itself. Stars within them fuse hydrogen into helium, helium into carbon, carbon into oxygen, and so on, building the elements needed for life. Supernovae and stellar winds scatter those elements into space, enriching future generations of stars and planets. Every atom in your body, your bones, your blood, your brain was forged in a star within a galaxy. You are, in the most literal sense, a child of stardust. The story of galaxies is not only about what they are, but what they reveal. They show us how the universe has changed over time. By observing galaxies at different distances, we see them at different ages, a cosmic time machine stretching back billions of years. Distant galaxies appear smaller, bluer, and more chaotic, reflecting a younger universe still discovering its shape. Nearby galaxies appear settled and refined. Through them, we trace the entire history of cosmic structure, from the first sparks of light to the complex archipelagos we see today. The fate of galaxies depends on the fate of the universe itself. If dark energy continues to push space apart faster and faster, galaxies will drift away from each other until everyone beyond the local group becomes unreachable. In the far future, the Milky Way and Andromeda will merge into a single giant elliptical galaxy, sometimes called Milkdromeda. Long after that, star formation will slow, stars will grow old, and galaxies will dim. But for now, they burn with the energy of countless suns, enriching the universe with light and life. And when we look at them, we're not just seeing distant islands, we're seeing possibilities. Each galaxy may contain billions of planets, and on some of those planets, life may have found a way. Somewhere, perhaps, a civilization is looking back at the Milky Way and wondering the same thing we wonder: are we alone? In the end, galaxies remind us that the universe is both vast and connected. Each one is a story of gravity, light, and time, a floating city of stars in a sea of darkness. They show us that from the simplest beginnings, complexity can arise. From chaos, order can emerge, and from darkness, unimaginable beauty can form. This is Mattermosaic, piecing together the universe, one discovery at a time. If this video sparked your curiosity, leave a like, share it with someone who loves science, and subscribe to keep exploring the universe with us.